Hello and welcome to K-Kaps CPD Presentation. My name is Gary Little. I am the Commercial Manager at K-Kaps International and I will be narrating the slideshow for you today. The presentation takes about 15 minutes and covers a number of brief topics related to block and beam floors and associated damp protection. The topics will include the makeup of a block and beam floor, how the beams are manufactured, the regulations we are addressing, some of the challenges related to meeting the regulation, the moment of inspiration that led to the K-Cap, some K-Cap product information, and a short case study. This schematic shows the basic makeup of a block and beam floor. Whilst this diagram is using concrete blocks for infill, there are also a number of proprietary systems that use specialised insulated infill. The type of infill has no impact on the use of K-Caps or how the beams should be protected from damp. The key points to note: the concrete beams are pre-stressed with steel reinforcement running the length of the beam. The beam will always sit below the main DPC level of the building, and this means the reinforcement at beam ends may be exposed to moisture in the cavity void. Here's a section of beam where you can see the ends of a beam that has been cut. The arrows indicate the ends of the reinforcing steel bars, or known as the rebars. This is the steel we are protecting, and this is the steel that sits in the foundation void that may be exposed to moisture. This slide talks about the manufacturing process for concrete floor beams. These pictures show part of a concrete beam manufacturing plant. To give you a sense in size and scale, the building is about 200 metres long and the machines shown are the size of a small to medium car. Concrete floor beams are manufactured by filling a mould or extruding concrete on an automated bed. For either method, the wet concrete is laid in lengths that can exceed 100 metres. The concrete is left to cure, which may take a few days depending on the environment. Once it is set, the beams are cut to length by a cutting machine. The beams are cut to stock sizes or bespoke lengths determined by each manufacturer's customer requirements. Across the many concrete beam manufacturers, there are many different profiles for concrete floor beams. The only standard sizing is the 100mm for the infill product. I will refer back to this point later in the presentation. A key point to note is due to the beams being cut to size, the reinforcement steel will always be exposed at the beam ends, as shown in the previous slide. The ends will not be covered in concrete like some other pre-stressed concrete products such as lintels. This slide documents the regulation and the requirement we are concerned with. It can be achieved with a number of approaches, including the use of a K-Cap. The requirement is clear, although not always completely followed or understood. The requirement: any suspended floor of in situ or precast concrete, including beam and block floors, next to the ground, will meet the requirement if it will, 1, adequately prevent the passage of moisture to the upper surface, and 2, if the reinforcement is protected against moisture. I have added the number of points and underlining in the extract from the regs to highlight the two parts of the requirement. 1, protection of upper surface, and 2, protection of the reinforcement. The next slide covers the challenges of meeting both requirements. This picture shows part of a block and beam floor under construction. It is helpful as part of my explanation as it also shows the base of the external wall and the cavity void. This is a fairly standard method of laying the beams on DPC material, which gives protection to the upper surface. The point to remember is that the main building DPC will sit on top of the beams once the block and beam floor has been completed. The yellow arrow indicates a point of possible compromise in setting the beams on DPC material. A 3.6 metre length of beam, a fairly standard size, can weigh 140 kilograms. This weight, combined with rough edges of the concrete, can easily move or tear the DPC material as the beam is being manoeuvred and positioned into place. The red arrow indicates that if the ends are not covered, the reinforcement is not protected, as it is exposed to any damp in the cavity void. As mentioned on the previous slide, there are a number of ways of protecting the reinforcement, and I will cover these in the next slide. In the areas of the country where building control are asking for both points of the regulation to be completed, there are some common options being used to protect the beam ends. These are, in no particular order of preference, painting with bitumen paint or blackjack. This is effective, although bitumen will eventually harden and crack, potentially compromising the protection. It can also be messy when trying to apply on site, particularly in inclement conditions. Another option is to lay the beams on a 400mm wide DPC with the excess wrapped over the beam ends for the complete length of the floor. This will meet both parts of the regulation and has the inherent longevity required. A downside of this method is that if the building was subject to a major flood, the DPC material will trap the water at floor level and prevent it dispersing into the cavity void. A third method is creating a wrap for the beam ends from DPC material and gaffer tape. This does not give full protection, is very time consuming to complete, and increases the manual handling risks as the beams need to be lifted to complete the wrapping process. The final method I describe is the use of a proprietary plastic cap. This is simply slid over the beam ends before the concrete beam is set in place. The cap provides full protection for both parts of the regulation. So how did the K-Cap come to be developed? Well, Hertfordshire builder Kevin Nutkins, who is now the owner and founder of K-Kaps International, had been working on a number of projects where he was frequently asked to provide the beam end protection. The local building control inspector had advised him to wrap the concrete beam ends. Kevin was complying with this, but found the whole process very time consuming, as it takes several minutes to complete each beam end. The other issues that would bother him were the fact that the wrap doesn't give full protection due to the shape we're trying to cover, and the amount of additional lifting needed on each job. After an amount of deliberation on how to improve the situation, he had a moment of inspiration. How about I cap the ends rather than wrap them? This started a train of events that led to production of the K-Cap and our slogan, "Don't wrap it, K-Cap it." So how was the K-Cap created? The development of the K-Cap took close to 2 years from Kevin's first idea until first commercial production in early 2019. After a number of designs and materials were considered, it was decided that recycled polypropylene was the most appropriate material. Injection molding was the production method chosen as it is an established process and can provide the best mix of volume and cost. 3D printing was used to make final prototypes, but it's not suitable for volume production. Before bringing K-Cap to market, we ensured it was fit for purpose by having it fully tested at the building research establishment. The cap passed all the testing criteria for damp-proofing material and use as an underground building product. The full certification report is available on request should you wish to understand the detail further. K-Kaps International has worked closely with LABC as we developed our product. We are proud to be an LABC innovation sponsor and to be able to share information about concrete floor beam damp protection at the technical roadshows. Before launch, we ensured the K-Cap was a registered product with LABC and that its use was approved by LABC warranty. Our attendance and information sharing has been very well received at the technical roadshows and at the annual conference. This is something we will continue through 2020. K-Kaps are manufactured in the UK from 100% recycled polypropylene. These are two key principles of our business which we have no plans to change. UK manufacture ensures we can easily maintain good quality control and easily flex production to meet customers' needs. Using recycled materials helps the global need to remove plastic from the environment. Our current product was designed to fit the profile of beams manufactured by Supreme Concrete. It also fits concrete beams from Cemex, Lynx, FP McCann, Frontiera and Millbank. Finally, on this busy slide, I'm pleased to share that our product was announced as Best Innovation Zone Product at UK Construction Week and received the Top Product Award by Professional Builder magazine. So some words on future developments. I have mentioned previously in the presentation that there is no standard profile for concrete floor beams except for the 100mm for the infill blocks. Recognising we will need to address the other profiles if we are to provide protection for all manufacturers of concrete floor beams, we have prototyped several other K-Cap sizes. These will go into production once we begin to see an increased demand for these other sizes. It's most important that we continue to work with LABC at roadshows and conferences to raise awareness of the requirement. I look forward to hopefully meeting some of you if you attend any of these events in the near future. To make K-Cap easily available, we continue to work with all the major builders merchants to increase stockists of products. We are working with beam manufacturers for them to stock and supply K-Caps with their beams, and we have recently implemented online ordering from our website to ensure K-Caps are available nationwide. This and the next slide look at a simple case study from Wilson Developments, who are based in Watford, Hertfordshire. They were building a 3-bed detached dwelling and using block and beam for the ground floor construction. The plans showed the need for 35 concrete beams in the floor construction. Wilson Developments' previous approach was to wrap the beam ends with DPC material and gaffer tape. To do this adequately would take the best part of a day's work, as it takes about 15 minutes per beam. By using K-Caps for the beam end protection, this time is reduced to less than 30 minutes, as it takes seconds to fit each K-Cap. Some positive words from Dean Smith, the director at Wilson Smith Developments. The use of K-Caps on this project has saved us considerable time and ensured that the beams are fully protected. The LABC inspector was very positive about how easy it was to see the beam end protection was complete. The time savings are obviously a great benefit, however the reduction in manual handling should not be forgotten, as capping will prevent additional lifting of the beams. The point about the LABC inspector being positive and the visibility of the protection has been mentioned to us from other jobs and contractors. We will ensure this positive message continues to be shared at the LABC technical roadshow. So as I close this presentation, we come to the final slide. There is plenty more I could share, but the information is available on our website and I would encourage you to visit it. This information includes technical information including product dimensions, installation instructions and information on setting out a block and beam floor using K-Caps as a damp protection, videos from building sites showing the product being used, and links to technical articles recently published in professional journals. By all means, please get in touch if you have any questions about the CPD presentation or any other aspects of K-Kaps International. Thank you for watching and listening.